Hey there, my AP students. Good morning. Sorry this one's a little late this week, but I've got kind of a short problem for you. I'm going to try to do it in 10 minutes. So, a large company has two shifts, a day shift and a night shift. Parts produced by the two shifts must meet the same specifications. The manager of the company believes that there is a difference in the proportion of parts produced within specifications by the two shifts. So what that indicates to me is that there are some parts that have to be either remanufactured or tossed. So to investigate this belief, random samples of parts that were produced on each of these shifts were selected. For the day shift, 188 out of 200 selected parts met specifications and for the night shift, 180 of its 200 selected parts met specifications. So they selected a total of 400, but 100 for the night shift and 200 for the night shift and 200 for the day shift. So we've got proportions here. This is definitely proportions, and I've got two proportions. I want to compare two proportions. So if you identify that part of this question, you're in pretty good shape right there. So this one should go pretty quickly. It's going to be a two-prop, but I'll write that in a second. We need some conditions. Now the conditions might take the most time here. Is it an SRS? Yeah, that was given. And I always like to quote the part, random samples. Samples from each shift. Okay, I'm also trying to write this in such a way that I think it would be acceptable to the AP as well. Is it independent? So in this case, yeah, I think we're going to say the 10% rule definitely applies. I think we have to assume that the population of parts produced in a shift I guess I probably shouldn't skip that in a shift, times 10% is greater than 200, and we're going to assume more than 2,000 parts. Are produced in a shift. All right. And is it normal? Well, n times p has to be greater than or equal to 10. So is n for the day shift 188 over 200 times 200 and greater than or equal to 10? You bet it is. It's 188. And is, put a little check mark, and is 1 minus 188 over 200 times 200 greater than or equal to 10? Yes, it is. That would be 12. All right, and night shift, I'm going to do the same thing. Sorry, I had a little brief thought there. 180 over 200 times 200 is greater than or equal to 10. I didn't take the time to change that into a decimal. It would make some sense to do that. That's true. And 1 minus 180 over 200 times 200 is greater than or equal to 10. Yeah, that's definitely true. Okay, so our conditions are met. And what we want to do now is we have two props, two proportions. So it is a confidence interval and a 96% at that. Well, if we use the calculator, that's not going to be a problem for us at all. So I'm going to go to Stat, over to Tests, which is where my intervals are. I'm going to go down to my intervals, and it is a two proportion Z int. Why is it Z? Because proportions are always Z. And my first number, you can see I kind of tested this a little earlier, my first set of good parts was 188 out of a total of 200. That was our day shift. Our second was 180 out of a total of 200 selected on the night shift. I want a 96% confidence level, and I'm going to write this down. 2 prop Z int x1 is 188 and 1 200, x2 180 and 2 200, confidence level 0.96, and then I'm going to go ahead and calculate that. I'm sorry, I think I was writing below where you could see. So I'm negative 0.0156 to 0.09557. P hat 1 is 0.94. P hat 2 is 0.9. And we've already got our n values written in. I don't think we need to write those again. So we're 96% confident the true proportion of defective parts is between about negative 1.5% and about almost 10%. Or the true difference in parts that are defective. The true difference in defective parts or out of spec parts between day and night shift let's add an S to that. Day and night shifts is between negative 0.0156 and 0.09557. I never write those zeros before the decimal point, hardly ever. All right, so we've gotten the confidence interval. Now, the important question, based only on this confidence interval, do you think that the difference in the proportion of parts produced within specifications by the two shifts is significantly different from 0? Justify your answer. This one is easy. We're going to draw the curve. We've got a 96% confidence interval. So 96% of our sample should fall between these two values. And the values are at negative 0.0156 and 0.09557. Where is 0? 0 is in the confidence interval, so 0 indicating that there is no difference between the two shifts. It's plausible that there's no difference because the 0 is within the confidence interval. It is plausible that there is no difference between the two shifts as 0 falls within the confidence interval. And that should get you a 4. If you look at the answers that they give from 2006, things are a little different now than they were then. You couldn't have used this in 2006. You would have had to write out the formula. But now this is acceptable. You definitely have to get your conditions. You've got to have a conclusion. You've got to write down what you've put in and what you've gotten out of the calculator so that they know what you've done. And you have to assess it correctly in context. You do that, and you're good to go. All right, guys. I hope that makes sense. By all means, if you have any questions, you can stop by at any time. I'll talk to you later.